Alright guys, let's go over that homework from last night. This is simplifying rational expressions. Okay, what we have here is a rational expression. It's a fraction with a denominator and a numerator. And we have to see if we can cancel some things. Remember, the things you can cancel have to be multiplied to something else. So what I have here is we have a 45 that's multiplied to an n, and then it's multiplied to 3 other n's also. If I think about n cubed being the same as n times n times n. And that's all over 20 times 7 n's. 3, 4, 5, 6, 7. Alright, first question for yourself. Can I factor? Well, you just did it. You took those 3 n's, the cube there, and turned it into 3 n's. Took the 7 and turned it into 7 n's. That was technically some factoring that you did. Now that we're factored, our next question is, can I cancel? The way we cancel things is by finding sets of ones, something over itself. I have an n over an n over an n over an n, with an m left over on the numerator and an n left over, 4 n's left over on the denominator. Let's go there for now. Last thing I do is cancel out or reduce my fractions with the numbers. And the easiest thing in this fraction here would be to divide by 5. But here's a different way you can do it that's similar to canceling the n's that I just did. Think about the factors of 45. You can make it 9 times 5, or even 3 times 3 times 5 if you break up that 9. Times the n we have already over there. 20 is 4 times 5. If I'm going for prime factorization, I could make that 2 times 2 times 5. With my n to the 4th left over. Now instead of having to reduce a fraction, I have things I can cancel again. I got 2 5s. What's left over here is 3 times 3, or 9, and an m over 4 n to the 4th. Okay, let's do number 2. I have nothing to cancel on the numerator, but down here in the denominator I have a difference of squareds, a squared minus b squared. That's a pattern that you kind of just have to memorize as the 2 factors subtracted times the 2 factors added together. Question, can I cancel? You bet. There's 2 things that match. The a plus b. The common error here is that canceling out a plus b does not make it 0. We cancel it out because it's 1, because it's the same thing over itself. So in my final factored form here, I need to keep a place with 1. And then what's left over was that a minus b. Plug that in there, and you're done. Okay, moving on to number 3. Look up here, what kind of special pattern is that? What kind of special polynomial is it? Look at that, it's a square, so it's quadratic and it's a trinomial. Which means when we go to factor that, we're going to get two binomial factors, two terms, that have a product of 9 and a sum of 6. 3 times 3 is 9, 3 plus 3 is 6. Throw your x's in there. Nothing to factor down there on the bottom, so we'll carry over the x plus 3. Second question for yourself, can I cancel? Cancel things that match x plus 3 over x plus 3. But uh-oh, look what happened. We canceled out everything on the bottom. It's okay. Because just like in the last problem where we canceled out everything on the top and there was a 1, this time we could cancel out everything on the bottom and there's a 1. Oh, and we made it look even prettier. Because guess what? You know that something over 1 is just itself. This one comes out nice and nice to x plus 3. Let's go ahead and do number 4. Everything here is multiplied together. So everything is fair game for canceling. Nothing is restricted. Think about all the different factors here. Factors of 36 are 6 and 6. I'm going to write that as 3 and 2. Just in case the factors of 54 cancel out with that well. Then I have 3 C's and 2 D's. And this is things all you could do in your head once you get better at this. Certainly as you're starting, it's probably better to write it out. Just like you did when we were doing exponent rules a few chapters ago. Factors of 54 are, that's 9 times 6. If I break up that 9, that's 3 times 3. And that 6 is 3 times 2. And I have 1 C and 5 D's. We are factored. What's next? Cancel. I got some 3's. I got some 3's. I got some 2's. C over C. D. D. What's left? I have a 2. C squared. 3 in the denominator, D cubed. If you remember your exponent rules, again, that's another way you can do that problem too, a little bit quicker. This question number 5 is a little bit tricky because there's an unwritten step that we have to do. But let's write it out for you. Factor. Factor it out. I can't cancel anything right now. Nor do I know what I could plug in for 0 in the denominator to find that is undefined. But what can we factor? Hey, there's a trinomial. Let's do it. Keep y minus 4. That's a trinomial, so I'm looking for factors of that last number, negative 12, that have a sum of negative 4. Let's change to the factor color. Negative 12, 3 and 4. Nope, not going to work. 6 and 2. Oh, I could do negative 6 and positive 2. Let's kick it. Y minus 6. Y plus 2. If I were to add those together, I would get the negative 4 from the trinomial. Next question. Cancel? Is anything the same in this factored rational expression? Nope. But now we need to see what can make things 0. That's the undefined section of this question. If I plug a positive 6 into there, it would be 0. If I plug a negative 2 into there, it would be 0, which would make the whole denominator 0. So this is undefined at y equals negative 2, 6. If you did that out of the book, you had multiple choice, and that should have been one of your choices. Last one, number 6. Here we go. Oh man, this is the hardest, I'll be honest. Let's things that we can factor. Let's do it. Is the top a difference of squares? Well, 9's a perfect square, 3 times 3, but 6 isn't. Can I take a common factor out? Oh, I sure can. Let's take out a 3 and a y squared. Took out a 3y squared. Out of there, what's going to be left over is a 3. And out of here, negative 6 divided by 3 is going to be negative 2. And y cubed divided by y squared is going to leave me with y. Okay, there's the top, factored. Bad news. Here's the bottom. Also still have to factor that. And what's even worse is there's a 2 as the leading coefficient. That's okay, because you did things like that in chapter 5 earlier in algebra 2. You can do that, because you remember that you have to do 2 times negative 12 or a times c. I'm going to scooch this over here to give us some room. So you're going to do 2 times negative 12, and you're going to get factors of negative 24 that have a sum of 5. Oh, red's my factor color. Let's get red. Negative 24 factors that have a sum of 5. 8 and 3. Negative 8, positive 3, or positive 8, negative 3. Hey, what do you know? 8, negative 3. Okay. Split that middle term up. Split up that 5. Keep these. Let's put, I'm going to put negative 8 there. Leave your y. And positive 3 here. Leave the y. Don't combine your like terms. You just split up the like terms. That was on purpose. Now I have 4 terms, so I'm going to factor by grouping. Group. Whoop. Group. Whoop. Look for a common factor. I can divide 2y out of this first set. 2y. Y would be left over. Negative 8 divided by 2 would be negative 4. I can take a 3 out of the first set there. 3 is positive 3. Y minus 4. Other good news, you're a factor master. So your 2 binomial factors matched up. Put in what you factored out. 2y plus 3. Y minus 4. You are factored. All that is grand gravy news, just to go back to our problem. So remember, on the numerator we had 3y squared times 3 minus 2y, and we had 2y plus 3 that we just factored with a y minus 4. And then you say, I factored! Super! Let's cancel stuff! Ooh, but look. Things are close. This is close to that, but not quite there. Boo-hoo. This is where, if you looked at the example in the book, you can factor out a negative 1. You can do that out of anything. We're going to do it out of the numerators 3 minus 2y to get that negative 2 to be positive. Hey, you know what Mr. Baker did? He made a mistake. Did you catch it? I hope you caught it. What did Mr. Baker do? He used the wrong factors. Look here, we said 8 and negative 3 were going to get us positive 5. Mr. Baker wrote negative 8 and positive 3. So let's scooch back and see if we can fix that. No scooching. Okay, we'll write over it. This needs to be positive 8. This needs to be negative 3. Which means I'm going to take a negative 3 out there. And that's going to be negative 3. And this is going to be negative 3 here. Hopefully you can erase instead of having to make darker lines like me. Okay, this is good now. This is what we wanted. That's how I knew that I was wrong. Because to divide out that negative 1, you want different signs on your two terms in the factor. See here that I have a negative 3 and a positive 2y. And here I have a positive 3 and a negative 2y. Let's divide out or factor out a negative 1 on the top there. What's that going to look like? Remember, factoring is just dividing. So back in the numerator, I'll stick with orange, that's my numerator color. I have 3y squared, remember. Now I have a negative 1. If I divide 3 by negative 1, then I'm going to have negative 3. If I divide negative 2 by negative 1, then I'm going to have plus 2y over what we had in blue still. 2y minus 3. Y minus 4. Are you still wondering why they're not the same? What can we do? Let's reorder our terms. Negative 3 plus 2y. Because it's addition now, it's commutative is what the rule for that is called. And so we can rearrange the order of those two. So our last little kick, I'm going to put that negative 1 on there. Make it negative 3y squared times 2y minus 3 all over 2y minus 3 times y minus 4. Can we factor any more? That has a degree of 1, y to the first. 2 and 3 don't have a common factor. There's nothing else multiplied or divided together up there. That has a degree of 1. That has a degree of 1. No common factors. Oh good, we're done. Time to cancel. Somebody cancel it. What's canceling? There we go. What's left over? Negative 3y squared over y minus 4. Let's take this last opportunity to think about what would make my little function in purple there undefined. If we were to put maybe a 4 right there, that would make the denominator 0, right? So this is undefined at y equals 4. Good luck.